Sorry. Okay, on 4.8. We're kind of still talking about how to solve quadratics, but we are talking about a few different methods that we may use and some real world problems in 4.8. So on this first one down here, it says, well, in order to even start solving this, you're going to have to factor it. And by that, we mean we're going to look at both of these terms. We're going to look at the 18 and we're going to look at the 27. And we're going to see, well, is there something that is, what's the biggest number in 18 that is also in 27? And that may be difficult for some of you guys to have to kind of think about that, but there is actually a number that I could pull out of both of those, and it's 9. Okay, 9 will go into 18 2 times, so we would put a 2 right there. And 9 will go into 27 3 times. So we would divide both of these by 9 and pull that out front. Okay, and then on the part that has the letter with it, or the variable, you want to pick which one's the smallest one. They're both y's, but you want to pick y to the 8th power because both of them at least have y to the 8th in them. If I take a y to the 8th out of y to the 9th, I'm left with just a y. And if I take a y to the 8th out of y to the 8th, I wouldn't have any. And when you're doing this, what you want to make sure you're doing is you want to make sure when you go back and you multiply this stuff back out, that you actually get what you started out with. So if I do 9 times 2, I should get back my 18, and I do. If I do y to the 8th times a y, I should get y to the 9th, and that is true. So then you would do the same thing to 9y to the 8th times your 3. Well, 9 times 3 is 27. I'm not supposed to just get a 27. I'm supposed to get negative 27 or minus 27. So I need to put a minus sign right there to make that work. 9 times negative 3 would give me negative 27. Y to the 8th times nothing, I'd still get my y to the 8th. So when I factor this, this is what it looks like. I have pulled out the biggest thing I could come up with that would go into 18 and 27. That was 9. And I also took out my biggest variable, y to the 8th, because there was at least a y to the 8th in both of these terms. Okay, so that's factored. Is everybody okay with that? On this one, we're doing the same thing. I'm going to look at the numbers first. I've got a 12, a 48, and a 12. What's the biggest number that you can think of that you can take out of 12 and 48 and 12? 12. So when I take a 12 divided by 12 is just 1, so I would just have an x squared in this place. 12 will go into negative 48, negative 4 times, but I still have this x there that I haven't messed with. And then the last term, 12 will go into 12 1 time, and it would be positive 1. Okay, don't forget to go back and multiply out to make sure that you got whatever we started with. So 12 times x squared does give me back my 12x squared. 12 times negative 4x is negative 48x, and 12 times 1 is 12. It's possible for you to keep going and go, is there something that, use the calculator or your brain to go, is there something that multiplies to 1 and adds to negative 4? If you did this on the calculator, you would type in 1 for A, negative 4 for B, 1 for C, remember, and we would try to keep factoring it out, but there's not going to be anything that multiplies to 1 that adds to negative 4. So I can't do this next step. This is all I can do. Okay. So sometimes there is a number that is in each term that you need to factor out. This is very similar to what we just did. So we can work these using our brain, like we said, or we can work them using our calculator. But either way, on this first problem, it has the m squared in it. It has the regular m. So I have to do a little bit of math at least to just get this equal to what? 0. That's the first thing you've got to do is get this thing equal to 0. So this would be m squared minus 2m minus 8 is equal to 0. From there, right? I can use my calculator and I can type in A is 1 on the quad program, B is -2, C is -8, and when it would give me some answers. Or I can factor this. I'm going to go ahead and work it the long way just to make sure you guys know. So I'm trying to think of what multiplies to -8 and adds to -2. So X -4, it's not an X, it's an M, sorry, bad habit. M -4 and M +2, because -4 times 2 is -8. But when I add them, I get -2, and that's what I needed. I need something that multiplied to -4 and added to -2. So a lot of you that are already doing this on your calculator, you're getting those answers because we're setting these equal to 0. And if we add 4 to this side, we would get M is 4. And we would get M is -2. And those would be the two answers. Those are our x-intercepts, right? Our roots, our zeros. Questions about that? Okay, I'm just wanting to remind you that you can work this the long way if that's what you want to do. It's fine to do that. So this one has to be equal to 0. So I would get, if I subtract 3 from both sides of the equal sign, I'm going to get 11y, and well, I'll go ahead and 4y squared minus 3 equals 0. And usually we're used to seeing this, going to just rearrange it because we're used to seeing it with the y squared, then the y, then the -3 equals 0. When for this one, we drew that big box and we tried to brainstorm about what would work. I don't know if y'all remember that, but we drew this box because this one was a little bit different. We had something in the front of the y squared. So it's not as easy as just thinking what multiplies to -3 and adds to 11. We had to do a little bit more work here. The calculator will absolutely find the answer if you were to plug in A is 4, B is 11, C is -3. We'll do this stuff for you. But I know that 2y times 2y, that's 4y. I'm just kind of brainstorming about what I would get for my answer. And actually, since I know this middle term's 11, I know I want something big to get me to 11. So I'm going to go ahead and leave this be a 4. So 4y times 1y would get me 4y squared. I'm going to let this be a 3, and I'm going to let this be a -1. 3 times -1 is -3. And remember, these middle terms have to add to get you your 11y. So 4 times 3 is 12y, or 4y times 3 is 12y. -1y times 1y is -1y. So when I put those two together, it gives me 11y. So I know that this and this is my answer to the factoring part. 4y minus 1 times y minus 3 is equal to 0. So then to finish the problem, you're going to solve it. So we would add 1 to both sides. We would get 4y is equal to 1. Then we would divide by 4. So one of your answers should be y equals 1/4. And y minus 3 is equal to 0. So all we would have to do is add 3, get 3. So y is 3 and y is 1/4. Those are our zeros, our roots, or y-intercepts, or x-intercepts. Questions about that? Okay, I don't expect you to do this the long way, but I'm just trying to give you a strategy if you ever get in that position, you need to do it, that you can kind of try to figure it out. This one is easy to solve without the graphing calculator. And so I'm definitely not going to go into the graphing calculator and solve this. Could I though? What would A be? It's already equal to 0, right? A would be 5. B is the number in front of X, but I don't have any. So B would be 0 and C would be -20. So yeah, you could absolutely do this problem on the graphing calculator too. If I'm just working this by hand, I'm trying to solve for X. I'm going to say 5x squared is equal to 20. I'm going to divide by 5. So these cancel out. X squared is equal to 4. I'm going to take the square root to get rid of the squared. And we kind of talked about this in the last class, but remember when you take the square root, it can have 2 answers. So it would be +2 and -2, or +2 and -2 are the answers. They're the roots. Questions about that? Okay. What if, let's cheat on this one a little bit. Let's go to the graphing calculator and let's type in. So A would be 5 here. B is -9. C is -2. If we do the quad program for this, I'm not going to pull this up on the screen. There is a video that shows that, but I'm just going to the quad program and I'm getting the answer. So I'm going program, quad. You could also use that calculator soup if you would like to. It's online. Okay, so I'm getting the calculator. The first answer the calculator is telling me is that X is equal to 2 and X is also equal to -0.2. If I hit enter again, which is what I want, because I don't like that 0.2, it tells me 2 and -1/5, right? We talked about a little trick that we had. So these are the actual answers, and that's what it's asking for. But if I want to go backwards and get the factoring part, I can use this. Remember, all you would have to do is go X -2 for this part. And remember, if it has a denominator, that goes in the front with the X. So the 5 would go in the front with the X, and we wouldn't do -1, we would do +1, right? So I do want you to know that you can go backwards, because there's sometimes where it'll say factor this and you know how to solve it, but you might have trouble factoring it. Well, you still can use that. You just got to go backwards. You got to think backwards. Questions? Okay, so this says to use the graph to find the x-intercept shown. Well, if we've got a graph, it's pretty easy that you can see that the x-intercepts are -4 and -4,0 and -2,0. If I just said, tell me what the zeros are, you would tell me what? -4 and -2. If I said, tell me what the roots, you're going to do the same thing, right? -4 and -2. You don't have to put the whole point when they say, what are the zeros and the roots? Okay, this one looks like it has an x-intercept at -1,0 and at 5,0. If I said, tell me the zeros or the roots, you would just say -1 and 5. But don't put the parentheses around it. That's confusing to some people. But if I go ahead and I do this, what am I saying? I'm saying that, yes, I'm saying that this is a coordinate, -1, 5, and that's not what we want. So we just want to say, yeah, we have zeros and roots at the point -1, X is -1, and Y is 5. Okay, questions about that? I feel like that part really is a review over what we just did last class. So a lot of this section is going back over what you just did, except for the next problems that are going to turn it up a notch. Okay, so we've got these real world problems that are everybody's favorite, but they're not real difficult. And I will say that these are a whole lot like what you're going to have in the computer lab. It's not a trick. So all of them involve this Pythagorean theorem. So we're working with a right triangle. A squared plus B squared equals C squared. You probably have heard that 5,000 times, but it's important that you know what parts the A, B, and C are. A and B are the legs of the right triangle. They are always connected to the right angle, and they're always the shortest too. The C that it has to be equal to is your hypotenuse, which is always your longest side, and C is always right across from the right angle. So we're going to use that Pythagorean theorem to solve these problems. So this first one, we've got, it's kind of hard to see this, but it's got H in here, and it's got D, and it's got 20 right here. So this says a wire is stretched from the ground to the top of a pole of an antenna tower. The wire is 20 foot long. The height of the tower is 4 foot greater than the distance D from the tower's base to the end of the wire. So they already have this distance. And it tells us the height is specifically equal to 4 feet greater than the distance. So 4, let me reuse a different color. So the height is equal to 4 plus the distance. Okay, and they want me to find the distance and the height. So at the end of this problem, I need to be able to say, well, the height is equal to, and the distance is equal to. That's what my goal is. So to solve this problem, we're going to use the Pythagorean theorem because this makes a right triangle. So the legs of this triangle would be the parts that are connected to the right angle. So D is one of the legs, so I would say D squared. It doesn't matter which leg you pick first, but I pick D squared or D first. The other leg is H, but I don't want to put H squared here because then I've got another variable. You want to try to only have one variable. So that's why you want to use this 4 plus D. So this is H, 4 plus D, and I need to square it. So far we've got A squared plus B squared. And that's going to be equal to C squared, which is the longest side, which is 20 squared. Is there anybody lost at this point? Okay, this is going to be quadratic because we're creating a D squared. So there is a little bit of some part that you can't do in the calculator yet. So we are going to have to kind of simplify this some first. So I know that 4 plus D squared means 4 plus D times 4 plus D. I know that 20 squared is 400, so I'm going to go ahead and take care of that. I need to use that first, outer, inner, last FOIL thing to distribute this. Bless you. So I would do D squared plus 4 times 4, 16. Then I would do 4 times D, so 4D. So I've done first, I've done outer, now I want to do inner, so 4 times D again. And then my last would be D times D, so D squared equals 400. Which is one of the reasons why we work so much about in the very beginning of this class is how to like get these simplified and combine like terms. At this point, you want to combine anything that you can combine. So the D squared and the D squared could go together. That's going to be 2 of those. The 4D and the 4D can go together. That's 8 of those. So we combined D squared, and we got 2D squared. We combined 4D and 4D together to get our 8D. And then what do we have left? We got plus 16 equals 400. So I'm going to kind of write this up here so I have a little bit more room. Can I do this problem on the calculator? Yet? No, but I can. Is it off the screen? Oh. That's right. We can do this problem on the calculator, but she's exactly right. I need to get it equal to 0 before I do that. So I need to subtract 400 from both sides of the equal sign. And then I can do 2D squared plus 8D minus 386 is equal to 0. So now I absolutely can do this on the calculator. I'm going to use the Polyroot simulator because I don't have the quad program. The quad program is easier, but just so that I'm showing you what I'm doing. So I'm going to my calculator. And I'm gonna go to the apps. Okay, so we do have 2x squared. And then what do we have? 8D, I think. And then minus 386. That look right? Okay, I'm gonna hit 384. Thank you for fixing that for me. Okay, so I'm gonna hit that I want it to solve it for me, and it tells me 12 and negative 16. If you guys use that quad program, is that what you got? 12 and negative 16? Okay, so on these problems, we're getting that D is 12 and negative 16. Think about this. Does it even make sense for the distance to be negative 16 from here to here? On these problems, there's going to be one of them that just doesn't make sense. So the one that doesn't make sense is the negative 16. You're not going to have a distance of negative 16 from the wire to the pole. So I know now that D, which is one of our answers that we were looking for at the bottom, we said this is what we're trying to find. D is 12 feet. We found that out from solving this quadratic. To find out what H is, well, I know H is 4 plus D, so H is 4 plus 12 because we know D is 12. So H ends up being 16 feet. And I had a young lady a little bit earlier that this being 16 has nothing to do with this being 16, right? Those are two different, it's just a coincidence. The reason that this is 16 is because we did 4 plus our D, which we found out was 12, and it just turned out to be 16 feet. Okay. How are we doing at this point? So we've got 2 more of these to look at. The foot of an extension ladder is 9 feet tall. So this part that is labeled 9 feet. It's 9 feet from the wall. The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. What's that? Close. 9 and 10 are consecutive integers. 20 and 21 are consecutive integers. So numbers that are right in a row, right? 100 and 101. Consecutive integers mean that they're just numbers right in a row, 2 and 3. So I'm going to have to pick some variables. Let's use X. And I'm going to have to decide, well, which one's longer? Is this part the height the ladder reaches on the wall, or the ladder longer? You can look at it and see which one's longer. The height that it reaches on the wall or the ladder? I mean, if you're leaning the ladder up against the wall, then the ladder should be taller, right? Because it takes up some of the length by just leaning it against the wall. So my consecutive integers, every single time if they say do consecutive integers, one of them needs to be X and the other of them needs to be X plus 1, because they're numbers right in a row. So if one of them's X, the other of them's going to be X plus 1. So since the ladder is taller, I'm making it be X plus 1, and I'm making the height against the wall be X. Okay, so we're doing A squared plus B squared equals C squared. So A and B would be our legs. So we want to say X squared plus 9 squared, because there's our A and our B. It would have been perfectly fine to say 9 squared plus X squared. That part doesn't matter. But the C is the longest side of the triangle, and that's the ladder, and that's X plus 1 squared. So A squared plus B squared equals C squared. Okay. There's not a lot of work to be done on this side. X squared, 9 squared is 81. I can figure that out. On this side, X plus 1 times X plus 1 is something I need to do. So I need to use that first, outer, inner, last to get that. X times X is X squared. X times 1, 1X. My inner two, 1 times X is 1X. And then my last two terms is 1 times 1, which is just 1. Okay, so I'm going to keep going because we know we can't do this in the calculator until we can get it equal to 0. So I'm going to look on this side. It looks like I could combine I've got a 1X and a 1X. Those could go together and give me 2X, but that's about it. So I'm going to kind of come up here. So far, I've got X squared plus 81 equals X squared plus 2X plus 1. So if I want this equal to 0, I got to start somewhere. So I'm just going to say, well, let's move this X squared so that it's on the same side. But what happens when I move that? They cancel out, right? This one turns into 0 and this one turns into 0. Well, that's okay, but I don't have a quadratic anymore because I don't have any X squareds. So now it's just turned into a linear problem. It's just an algebra problem. I would subtract 1, and so 80 divide by 2. And so X, these cancel out, X ends up being 40. So when I say X is 40, all I found is this right here. So this distance is 40. I know that now. The question says, how long is the ladder? So I need to do, the ladder is X plus 1. I just found X. So I need to say X plus 1, which is 40 plus 1. So 41 feet. When it asked me how long the ladder is, it didn't ask me this other part. Anybody lost? Okay. Mary's pool is 7 meters longer than it is wide, and it is 17 meters diagonally across. So I guess this problem might have been written back about 30 years ago. I don't know, but apparently they only had rectangular pools because it never says this. But we're going to have to make this be a rectangle to make this work in our problem. So we're assuming that we've got a rectangular pool. I do know that the diagonal means the distance from one corner to another, and they tell me that that's 17 meters. They also tell me that this is 7 meters longer than it is wide. So if we take the width, so both of these would be W, then the length of this pool, or L, the length of the pool would be 7 plus W. Because it says 7 meters longer than it is wide. So you do have some right triangles in here that you can look at. We just need one of them. It doesn't matter which one we use. If we look at the bottom one here, then the length and the width would be our legs. So they would be our A squared plus B squared. And our C squared would be our hypotenuse. So we could do 7 plus W. And I'm choosing to not use L because I want to use the same letter. So if I use the 7 plus W and the W, I'm keeping the letter the same, which is going to help me. And then the hypotenuse would be our diagonal, so 17 squared. So everybody okay with where we came up with that? Okay, so we're going to do 7 plus W times 7 plus W. 17 squared, 289. Yeah. So first, outer, inner, last. We want to combine anything that we can put together. So I know that I want to put, I like to write the squared parts first. So I know I've got two of those, so 2W squared. I can combine the 7W and the 7W to be 14W. Plus 49 is equal to 289. Are we going to be able to use our calculator for this? Yeah, but in order to do that, we need to solve it to equal 0. Did I write something down wrong, Nathan?
No.
Okay. You got to watch me because sometimes I get to going and then my brain works faster or slower than the rest of me. So I know I'm going to subtract 289 from both sides. So we've got negative 240 equals 0. So I should be at this point, I should be able to at least figure out what the width is because I can go to my calculator and I can type in use the quad program and type in 214 negative 240. So if you're following online, go ahead and find out what the roots are, what the zeros are. The rest of you go to your calculator. Tell me what did you get for W on this one? 8 and negative 15. Are y'all okay with that? Okay. So we know that one of them doesn't make sense. That's going to happen on these problems. We don't have a width of negative 15. Just mark it out. It's not the answer. So it says how long that question, and always make, this is what tricks people a lot. People will go and immediately type in 8. Answer the question, go back and look, how long is Mary's pool? We're not doing the width, we're doing the length. And the length is equal to 7 plus the width. So we have to do 7 plus 8, which is 15. And again, this is a coincidence that this is negative 15 and this is positive 15. Okay. Not going to happen every time that you get a real world problem that's going to work out that way. We got it because it was 7 plus what we had. Okay, so it's actually 15 and this is meters. So I'm going to put meters. That's the length of the pool. Questions about that? Okay. So that is the end of 4.8. And I had already warned you guys that we had to do 2 lessons today. So let me